Okay, so any questions from the last lecture? Just curious, so did you guys learn this kind of or very similar model from the microeconomic class this semester or last semester? No? Okay. I mean, I think I sort of learned this in my intermediate micro when I was in undergrad. Okay, in any way, so we were talking about the temporary and permanent income increase. And to define it more precisely, what I mean by permanent is that the current and future income both increase. And a temporary is just either future or just the current income increase. So in a way, they could be the same. Okay, so suppose I have a little bit of current income increase and a little bit of future income increase. I can go from this endowment to this endowment. Then, I mean, my new budget constraint would be this line. And this could be achieved by this amount of increase in current income and also by this amount of increase in current income. Future income. Basically, as long as you keep this amount the same increase, okay, then you are going to a new the same budget constraint line. So what I really mean by comparing temporary and permanent, I'm talking about, okay, so if I have an increase of current income like this, or a future income like this, if it is an or, then this is a temporary increase. But if I have both this increase and this increase, then I mean this is not exactly right, but so my increase is both on the current income and future income. Then that's going to be push me even further outside. The budget constraint is going to be pushed even further outside, right? That's what I mean by temporary versus permanent. So that's like this become used to be y1 and y1 plum. Now it's y2 plus y1 plum, or y1 plus y2 plum divided by 1 plus r, where y1 is less than y2, y1 plum is less than y2 plum. And this is temporary. And permanent is y2 plus y2 plum divided by 1 plus r. Think of it as this way. And this is related to a very famous hypothesis called the PIH, or permanent income hypothesis. Okay. PIH is basically saying that what happens to you in terms of income, what really matters to you is your permanent income. Okay, so a temporary increase for you doesn't change your permanent income by a lot, right? Think of it as 1 year is 1 period. Then you are, what age are you guys are? Around 23, right? Okay, 23 years old. Suppose you're 23, 24 years old. Then until you die, you probably have another, say, 60 years or 80 years, 70 years. Okay? So each year is 1 period. And suppose you know that one of those years, your income is going to be double in that year. Somehow you learned this fact today. Because that's just 1 period, it's not going to change your behavior by a lot. Because your permanent income doesn't change by a lot, right? That's only 1 period out of 60 or 70 period. But suppose this is a permanent income increase. That means all period your income is going to increase for, say, even a slight amount like 10%. That means your life or permanent income is increased by 10%. That is going to have a large effect on you. That's the permanent income hypothesis. Okay, now that's enough for the income. How about real interest rate? Remember, the slope of the budget constraint is just 1 plus R. And remember, in the sort of XY good model, what is the slope of the budget constraint? Something like P1 over P2, right? That's the price ratio. Or put it another way, it's just A price. Sometimes we just write a P to represent this ratio. Right? So this 1 plus R in this model simply is just a price. What price? Basically, it's the price of future good. Right? Okay, because $1 for now will become 1 plus R dollar in the future. If you don't spend that money, that $1, it will become 1 plus R dollar in next period. Right? So 1 plus R in the future dollar is equivalent to $1 today. So that's why it is the price sort of between when you compare these two. Or think of it as a price index. Okay. Think of the interest rate as some kind of inflation idea. $1 worth of money will become 1 plus R dollar tomorrow for everybody. So basically 1 plus R dollar is equivalent tomorrow is equivalent to $1 today. So I need to sort of deduct that inflation. Okay, that's why it is a price between these two periods consumption. Okay, so what difference between the XY consumption model and the consumption today and tomorrow model is that I will have one point that's called endowment point. This endowment point doesn't change regarding to the change of real interest rate. Why? I mean, it should be obvious, right? Because interest rate only matters to you if you lend money or borrow money. But you can always spend or consume exactly on your endowment point, which makes you not a borrower nor a lender. Even if the interest rate change, I mean, that doesn't concern you, right? I mean, if you don't have any savings in the bank right now, and if you don't have a student loan on you, you probably don't really care about the interest rate change, right? That's basically what it means right now here. So there's no change in endowment point, but the slope change, right? The slope is going to be from 1 plus r to 1 plus r, or r1 to 1 plus r2. And because the slope change, but this point do not change, so the effect is actually an increase of the budget constraint here, but a decrease of budget constraint here. So the interest rate change also change your total, your sort of lifetime wealth. Why is that the case? So remember, your lifetime wealth is y plus y plum divided by 1 minus r minus sort of t plus t plum minus divided by 1 plus r, right? That's your lifetime wealth. So if r increase, this goes down, this also goes down. And because, I mean, let's reorganize this to 1 plus t, 1 minus t plus y plum minus t plum divided by 1 plus r. This must be positive. Okay, so r goes up, this whole thing goes down. It means your WE goes down. So WE goes down, but obviously this one goes up because WE times 1 plus r is basically this 1 minus t plus 1 plus r plus y plum minus t plum, right? And the r goes up, this whole thing goes up because this is positive. In other words, these things must goes up, right? Okay. So basically, an increase in the market real interest rate decreases the relative price of future consumption good in terms of current consumption good. Right? The relative price change. And since it is a price change, it actually have, again, income and substitution effect. So you should be familiar with this type of model where, I mean, how to decompose the substitution effect and income effect. I mean, I don't want to go to detail about this. So like this is an increase in the real interest rate for a lender. What happened here, I mean, basically, this is the endowment point. Okay, so my original interest rate give us this budget constraint. Now this is the new budget constraint. And what I do here is I move this new budget constraint parallel back so that it tangent to the old indifference curve on this point D. So from A original optimal point to D, that's the substitution effect, and from D to B, that's the income effect. Notice that for this person who lend money out, this person makes saving and lend money out, right? For this person, increase of interest rate is a good thing or bad thing in general to this person. You're lending money to other people, and somehow you learn that the interest rate is going up. Good thing, bad thing? Good thing, right? I mean, the intuition should be clear here. I mean, is there a problem? Because I see some people's eyes are a little bit confused what I'm talking about. You're lending money to other people. Somebody's borrowing money from you, and the interest rate goes up. You're happy, right? The reason why you're happy is because you're gonna collect more money in the future. That means this is a positive income effect for you. So you see that from D to B, your C and C plum both goes up. The income effect is positive. The substitution effect always is the case that you will decrease the C, increase the C plum. And if this is the case for a borrower, so that the endowment point is here, the story is a little bit different. No, this one. Originally, your endowment point, your budget constraint is this one. Now the budget constraint is here. Yes, okay. Now the budget constraint is here. So here, what I do is a little bit different. I'm pushing this outside to point on this point, to tangent to the old indifference curve, I1. So again, from A to D, the original optimal, to this D point, this is substitution effect. Again, C goes down, C plus goes up. The same as here. But then from D to B, that's again the income effect. But from D to B, you can see that both C and C plum goes down. Right? Because this is a borrower. For a borrower, when the interest rate goes up, that's a bad thing for this person, right? Like, I mean, I have a loan right now on me. Actually, I have a student loan on me and a mortgage loan on me as well. And when I saw the news saying that the interest rate is going to go up, that generally make me poor, right? So my income effect is negative. Okay? So an increase in the market real interest rate decrease. So like I said, This is the same slide, actually. Just to recap again. It has income and substitution effect at the same time. Okay, and let's do a very simple example of perfect complement. So with perfect complement, the ratio of future consumption to current consumption is going to be a constant, right? That should be clear to you from at least previous model in previous example in chapter 4 and one of the assignment example for chapter 4. So let's assume that ratio is A, lowercase a. So the consumption to future is exactly A times consumption of today. Then the consumer's budget constraint must hold this. So we can know exactly that, this and this must both hold. So these two can lead to C is the wealth times 1 plus R divided by 1 plus R plus A. And C plum is A times that. So you simply put AC here and solve for C, you will get this. And C plum is A times C. So this, the only difference is there's an A here. Okay? And graphically, it looks like this. Okay. So, I mean, this is ideally how you can solve for a very simple example. Okay? And you can try to talk about, to try to evaluate what happened. For example, assuming that the endowment is here or the endowment is here, and see what happened to a change in price ratio, or the interest rate or price ratio, or the income. I mean, you will find that since this is a perfect complement case, so the substitution effect will disappear, right? Okay, now let's talk about the other agent in this model, the government. The government here is actually going to be super easy because this is not the focus of this model. The government's current period budget constraint is that it will spend, this is the government spending as usual. And how do this government, spend on this government spending? It must be the case that it has collect tax, right? So it used to be G equals T. That's the budget constraint for the government. Right now, in addition to the tax, I can also borrow money from the consumer. So this is bound. Positive bound means I'm borrowing money from the consumer. But if I'm borrowing money for this period, then in next period I have to pay back, right? So next period, the bound that I borrow times the interest rate plus 1, that would be how much money I have to pay back. And I have to spend some government spending in the next period. And I need to use my tax income in next period to pay back the bound that I owe to people and the government spending in the next period. And using a similar technique that we used for the consumer, basically I can...
这是我在网络
Sorry. This is what you'll get. You can combine these two together so you can see that the present value of government spending and the present value of the tax income. Remember, this is a capital T. is different from the lowercase t because this is the tax income for the whole society. We assume there are end consumer. We assume there are end consumer. Remember? Okay. So we say that this is a present value budget constraint because everything here is a present value tax, and present value government spending. So this is actually very similar to the old G equals T, right? It's just not one period. It's 2 periods, so you need to do a present value deduction. Okay, so in this model, the CE, there's 3 things that must hold. One thing is that each consumer chooses first and second period consumption and saving optimally given the real interest rate R. So basically, consumer is maximizing utility. And the government, for the government, present value budget constraint must hold. And then credit market must clear. So the only problem that I haven't talked about is the credit market, right? So what do I mean by the credit market must hold? So every consumer has a saving lowercase s, right? This is maybe saving for consumer 1, saving for consumer 2, all the way to saving for consumer n. We totally call this capital SP. P stands for private. That's this SP. That's the private saving, total private saving. And I mean, we can assume that consumers are lending and borrowing money from each other. Okay? But if that's the case, that means some people's saving are positive, some people's saving are negative. But eventually they will cancel out, right? So what I mean by total saving, this number, it must be some number. And if this is negative, that means that overall, the private sector want to borrow money. But if this is positive, overall, the private sector want to save. And this is the total saving. And the total saving must equal to the bound issued by the government. Because, so let's say everybody's saving, okay, somehow, because in this, let's assume that everybody's saving because the endowment is so that current period is, assume that the current period is your middle age, next period is your old, so that your current income is high, but your future income is low. Then most people will save. So this is positive. But if everybody is doing a saving, who is borrowing those money, right? This is a general equilibrium model. So it must be the case that the government is borrowing those money. So I must have SP equals bound. And since I know the total saving is also equal to the total income, and that's summation of Y, this is summation of C, and this is just the total tax, right? Saving must equal to the income minus consumption and minus tax. That's the in total. And these two together, I know this is B, right? And B equals G minus T. So I can put it here. This is G minus T, then the minus T part goes out. And the minus C can go here. Again, I have y equals c plus g. That's the expenditure identity. So basically, that's the credit market equilibrium condition. Y equals c plus g. Okay, this is what I mean by credit market must clear. This is basically the credit market supply, and this is demand. So supply must equal demand in that market, but eventually what I mean by total, what I mean by equilibrium condition is simply it will lead to this, right? It will lead to the fact that y equals c plus g, just like what we had before. Okay. So far, everything's okay? Okay. So for the last part, we're going to talk about the so-called Ricardian equivalent theorem. So what is Ricardian equivalence? So let's make a little bit more assumption about this model to make the Ricardian equivalence easier to explain. Okay, so let's assume that I'm collecting a lump sum tax and all the end consumer are paying the same tax. So if everybody's paying T and I have end consumer, N times T is the total tax that I collect. And that is basically T, capital T. And in next period, that also must hold, right? And I used to have this as T and T plum, and I can replace it now with NT and NT plum. But if I do that, I can take the N out. If I take the N out, it looks like this. It's 1 over N times the present value of government spending. And this is the present value of individual tax. So in other words, the consumer's lifetime tax burden is equal to the consumer's share of the present value of government spending. This is the share, right? Because there are N consumer. The share is 1 over N. Okay, and put this thing back to the individual's budget constraint. You'll find that becomes something like this. The present lifetime or present value of your consumption equal present value of your lifetime income and minus your share of government spending, 1 over N. Notice that there's no tax here. You didn't see any T here, right? You didn't see T plum here, right? This is exactly the Ricardian equivalent theorem. What I mean by that, notice that here, basically saying that timing of the taxation does not matter for the consumer. Right? Because the T and T plum doesn't appear here. So if T goes up and T plum goes down, because this thing must hold, if this thing hold, what I'm saying is, if you make this goes up, this is a constant. It must be the case that this must goes down, right? To make this stable, doesn't change. Right? So this goes up, this goes down. Does this change this budget constraint? It does not, right? And what do I mean by tax goes up, T goes up and T plum goes down? That means I'm collecting more tax in this period and fewer tax in next period, or vice versa. That's what I mean by the timing of taxation. When do I tax more heavily? The timing of my taxation. I can even make tax T equals 0 this period. But T plum must go up a lot. But does that matter for the consumer? Or vice versa, I can make T plum equals 0, but T must go up by a lot. Does that matter for the consumer? Based on what I just described to you, it does not matter at all, right? Are we clear? What is the Ricardian equivalent theorem? Okay. So if you see this on a graph, this is what it means. Okay. When there's a cut in current tax, that's T goes down, because it must be the case that T plum must goes up. So what it really happens to you as a consumer is this used to be y minus t, y plum minus t plum, right? And t goes down, but t plum must goes up. So you're moving to a new point, but you are on the same budget constraint. So you're moving from endowment point 1 to endowment point 2. For you, what happened? Nothing really happened, because what defines how happy you are is your optimal consumption bundle. Your consumption bundle is still A. Your budget constraint doesn't change. And I mean, your preference doesn't change. So nothing changed, basically. This is for a borrower, but even if you are a lender, no matter where you are and how you are taxed, it's just moving you along this line. But nothing really changed for you. That's why I said the timing of taxation doesn't matter. And on the credit market, what happened? So when taxation bundle change, for example, if T goes down, remember the government spending is financed by this, right? So if T goes down, this must goes up. But another place where here, for the current period, T goes down means this goes down, right? Because I mean, this is basically capital N times T. So T goes down, this goes down. But to finance the same government spending, it must be the case that B must goes up. Okay? So B must goes up. So, I mean, the government's demand on the credit market is inelastic. It's a straight line. So it must goes up, this bound must goes up to where? It will go exactly to where that it matches the new supply of private saving at the point where the interest rate doesn't change. Because remember, when I change the timing of taxation, it doesn't change individual's budget constraint. That means the interest rate does not change. So it must be the case that although my bound demand increase, but my supply, the supply also increased by the same amount, or not exactly the same amount, but to the point where the interest rate doesn't change. And why does the saving increase? I mean, again, if T goes down, what happened? T goes down means that I have more income today, right? So I want to save more for the future. Especially when T goes down, T plum must goes up. So I know I'm actually not more wealthier today because I will be taxed in the future. And so I have to save for tomorrow to pay those taxes. Right? That's why I must save more. The saving must increase. Okay? Are we clear about what is the Ricardian equivalence? Okay. No questions so far? Really? Okay. But obviously, the Ricardian equivalence might fail in practice. I mean, most people won't think that the timing of taxation doesn't matter. Okay, so why that's the case? One is the redistributional effects of taxes. What do I mean by that? We sort of assumed in the previous demonstration that when tax changes, they change by the same amount for all consumers. Right? Everybody's tax is the T goes up, everybody's T goes up. T goes down, everybody's T goes down. But if some consumer receive higher tax cut and some consumer receive a lower tax cut, then this could be different for different people, and this could change the equilibrium real interest rate, right? And in the future, when the higher debt is paid off through this higher future taxes, consumer might share unequally in this taxation. So that the burden of this debt might not be distributed equally. So T increase and T plum decrease, T decrease, T plums increase. We are assuming that this is equally distributed among all consumers. That's why it has this Ricardian equivalence. But if this is not the case, then the interest rate might change. And then everything's different. Another thing is the intergenerational redistribution problem. We sort of assume that everybody lived for 2 periods. And so T goes down, it affects you. And T plum goes up, it also affects you. Right? But it could be the case that the government can postpone the tax until even longer in the future. so that the consumer who receives the current benefit does not actually pay for this tax in the future. Either this person retire or just die. So assuming that there are 3 periods. Okay, I young here, middle age here, and retire here. So why T1, T2, T3. And now T1 goes up, but T3 goes down. But in this period, I retire, I don't pay tax. Then this will be different for me. For me, this is a real tax increase. Or put it another way, if usually it is the tax cut. So if the tax is cutting here, but increasing in the future, but in this future I'm retired, then I'm not actually paying those tax increase, right? Then for me, this is a real tax cut. Although a temporary tax cut, because it's not every period I have a tax cut. Then my budget constraint actually change, right? This is a real change for me. Then obviously the Ricardian equivalence will not hold. And then we assume that taxes are lump sum, but obviously tax can be non-lump sum. Like we actually talk about proportional tax in chapter 5 or 4, I forgot. So you should know that all taxes can cause distortions, right? So in that they changed, what do I mean by distortion? That means they changed the relative price. And the relative price here is the interest rate. So, but if the interest rate changed, then Ricardian equivalence obviously will not hold. Lastly is the so-called credit market frictions. Basically, here we assume there's a perfect credit market. What do I mean by perfect credit market? It means that the consumer can borrow and lend as much as they please, right? But in reality, for example, if you want to go to the bank and say, I want to borrow, say, 1,000 million, I'm pretty sure the bank won't loan you that much. Actually, the so-called 个人信贷, like a personal loan, credit loan, you can probably only loan up to, for you guys, it's probably going to be somewhere around 300K or something. Not that much. Okay. And also, I'm only talking about one interest rate, R, right? But if you have ever, go to a bank, you know that your saving interest rate is quite different from the borrowing interest rate, right? So there is a different interest rate for a borrower and a lender. In that case, the budget constraint won't look like the budget constraint that I draw to you, so that it will actually create problems for the Ricardian equivalence to hold. And actually, we'll talk more about that in the next chapter, basically next week. Okay? And in there, we'll talk about why credit market friction is a big problem for the macroeconomics. Okay, so for today, that's it. Any questions for today? Okay.